Hi everyone, I'm Nicholas Obeng and
I am Richard Oboh.
okay, so we are here to take you through the solution of problem 6.6 in the molecular thermodynamics of fluid phase equilibria by Prausnitz. Okay, so the problem is asking us to construct a TX and YX diagram for cyclohexanone and phenol system at 30 kilopascal with the available data. Okay, so Richard is going to start, then I'll come in later.
Thank you very much, Nicholas. Now, for us to be able to construct our TX1 and Y1X1 diagram, we need to first obtain our activity coefficient for our individual components. Here, our individual components are cyclohexanone and phenol. Now, using our given XX Gibbs energy and equation 647 from the test, we are going to obtain our activity coefficient. RT ln gamma I, which gamma I is our activity coefficient, is equal to the partial differential of the product of the total mole and XX Gibbs energy with respect to the mole fractions of component I. Now, dividing this equation by RT, we obtain our next equation. And substituting our XX Gibbs energy, which is equal to negative 2.1 x1, x2 into this next equation and performing a rigorous differentiation, we arrive at our ln gamma 1, which is equal to negative 2.1 times x2 squared, and ln gamma 2 is equal to negative 2.1 x1 squared, where x1 and x2 are our mole fractions of the individual components. Now that we are able to obtain our ln gamma 1 and ln gamma 2, we are going to combine the gamma 1 and gamma 2 with the Antoine vapor pressures equations to calculate our vapor pressures. Nicholas will continue from here.
Okay, thank you, Richard. Okay, so what we are going to do, so there's a map showing what we are going to do. So initially, we are going to assume x1 and x2, and we are going to calculate gamma 1 and gamma 2 from the equation Richard just derived. So using the Antoine vapor equation, we can make T as a subject, and starting with an initial pressure of 30 kilopascal, as it was given, we'll be able to estimate our T1s and our T2s. Using T1s and T2s together, we can find an average temperature. Put this temperature in the Antoine vapor pressure equation, then using the A and B, which was given in the text, we'll be able to get P1s, P2s. Then together with the gamma 1 and gamma 2, we will be able to estimate a very good value for the P1s and P2s, then go back to calculate our actual T1s and T2s. So we do this iteration a series of times so that we can get our value. So we use Excel to do this, as I'm going to share my screen. So as you can see over here, we're given the values of A, B, and C for cyclohexanone and the phenol. Then choosing our X values, we assumed 0.7, then 0.3 as our initial values. So from there, you can calculate your gamma from equation 2. You can calculate your gamma from equation 2, which is this, negative 2.1 x2 squared, negative 2.1 x1 squared. So after getting your gamma, then you can use the equation 4 together with the pressure, the initial pressure that was given to us to estimate the temperature. Then you do a second iteration, going through this process so that you get the values for the pressure and the temperature through this. So with the second iteration, you are going to get a pressure of 48.51 and a temperature of 401, which you can see there's a vast difference between the estimates. After the third estimation or iteration, you will get 48.36 and 402, which is not much of a difference. Then with the fourth iteration, you are going to get 48.36, 48.36, 402, 402. It tells you this is a very good estimate. So our values are converging. So we have our P1s and our T1s for x1 equals 0.7. So we did this from x1 equals 0 all the way to 1. So changing my x1 to, let's say, 0.5, I'm going to get different T1s and P1s. So starting with 30 kilopascal and going through the iterations, you realize that my third and fourth iterations have similar values for the T1s and the P1s. So we can conclude with that value. Then we do the same for all the other pressures, for all the other values of the x1. So I change to 0.3, it's going to change. So using that, you can calculate, you can plot your T1, x1, y1 diagram. And as you can see, this is our vapor phase, our liquid and vapor, and this is our liquid phase. And you can also plot your y1, x1 diagrams for the vapor mole fraction of cyclohexanone and the liquid mole fraction of cyclohexanone. Thank you for your time. I hope you enjoyed it.
Thank you very much.
Okay.